because we've been discussing now the general, the nth term for a geometric sequence, this should be an easier problem. If I look at it, I'm going from 5 to 10 to 20 to 4. I know my generator is multiplied by 2. And since that's the case, I can find my 0th term. Now, if you look going forward, I'm multiplying by 2. That means my 0th term, right, would have to be the number 5/2, which is 2.5. But I like to write it as 5/2, even though the answer doesn't have it that way. So you can see, guys, right now, this is exactly it. You can see here is my 0th term of 2.5. My multiplier is 2, and I'm raising it to the nth power. So definitely A is the correct answer for number 8. On this one, a lot of you actually just said, hey, $300 sounds good. Done, right? If you went out and you did it the other way, it's insane. And in fact, she really should take the first option because there's no way I could ever give her that much money, right? It's not possible. So if I'm doing the $10 a day for 30 days, that's pretty easy, right? 30 days at $10 each day is equal to $300. Now, if I go the other way, the penny doubling plan, right? All of a sudden, I'm starting with 0.01 cents. Now, this is kind of tough because actually, it's not that tough. This will work. Think about this. Every single day I'm doubling. So the next day is 2 pennies. And the next day is 4 pennies. Okay, and the next day would be 8 pennies. Now, you can already tell me what's the multiplier there. It's a half, right? Each time I'm multiplying by 1/2. So my multiplier, or my generator, is equal to times 2. And my 0th term is a little interesting, right? It's not 0, right? If you've got a 0th term that's 0, you never go anywhere because you're just multiplying 0 by a bunch of numbers. My 0th term is actually 1/2 of 1 penny, so it's 0.005. So this would be my sequence. It would look like this. Here's T of n, the amount of money that I would pay her on the nth day. And by the way, this is just how much I would pay her on that last day. To figure out how much money I would pay her in total, I'd have to add all these up. But the amount of money I would pay her on the nth day is equal to 0.005. What's that? That's half of a penny times my multiplier of 2 raised to the nth power. Now, I did do some calculations with that, and I think I probably have the wrong number. Let me go ahead and plug that in now. So if I go 0.005 times 2 raised to the 30th power, my calculator tells me, hello, that's what? That's $5,368,709.12. And by the way, that is only what she gets paid on day 30. If I want to figure out how much she would earn for all the days combined, I would have to add all the other ones up. Yeah?
Will you start at 1 cent?
I told you that, and maybe, but the thing is actually you're going to earn a penny on day 1, aren't you? Yeah, I think either one of those would work. You're going to earn a penny on day 1. So if I wanted to know how much money I earned on day 1, I really should put a 1 in there. And if I do that, 0.005 times 2 to the first power would equal 1 penny on day 1. So actually, I think that would be the correct equation. The big point is, of course, this is what you should choose, right? Small numbers become really big quickly because of exponentiation. Exponents are a powerful thing, but probably the smart thing to do is tell your daughter, like, look, your dad, there's no way, so just take the $300 because he's just being weird. Next question.